Okay, guys, we're gonna go over the lymphatic system today. So, what does the lymphatic system do? It has three functions. It drains excess interstitial fluid from your body's tissues. Extra, so excess interstitial fluids from tissues of your body. It transports dietary lipids because, fats and cholesterol, they're very difficult because they don't really dissolve well since, they're insoluble. So you would need the lymphatic system to carry them. And it also helps the immune system. So white blood cells and lymphocytes move over to the lymphatic system for much of their lifespan. So the fluid is very similar to interstitial fluid, but the only exception is there's more white blood cells, and in particular there's more lymphocytes. And it's very abundant in the lymph. And they do vary in color. More white blood cells means more milky, more lipids and dietary fats means more milky and yellowy. So the overview of the lymphatic system. So the circulatory system, so the heart and blood are all part of it. So the blood, let me draw it out. Here. So how it works is the blood leaves your heart through the aorta, right? So aorta, blood comes out, right? And it travels to the tissues of your body and enters into the capillary beds. And where the fluid is going to leave the capillary beds and become extra fluid, cellular fluid, and this fluid surrounds your cells. And the excess fluid that does not get returned into the capillary beds or vascular system are going to enter into your capillary bed of your lymphatic system. So let me recap that really quick. Okay, so blood leaves your heart through the aorta. It travels to the tissues of your body and enters into capillary beds where fluid is going to leave the capillary beds and become extracellular fluid. And excess fluid that does not return becomes the, the, the excess it's going to enter into your lymphatic system. So we start with the first one, right? So aorta blood comes out and then it's going to it's going to travel to the tissues of your body, right? It's traveling, traveling, traveling. And it enters these capillary beds, right? And it becomes extracellular fluid. But sometimes there's some excess. There's some excess. They're like, okay, like we're hanging out here. And it goes into your lymphatic. They become your lymphatic system. Okay, and then for the lymphatic system, it emerges, so it's going from larger vessels into larger vessels. So yeah. So and eventually the lymphatic vessels will also like dump all the lymph back into the cardiovascular system right before the blood enters the superior vena cava. And it picks up extra fluid that capillaries of your cardiovascular didn't pick up and dumps it all into cardiovascular. So how your body makes lymph. So your cardiovascular system contains a bunch of blood plasma. Blood plasma is the fluid in blood. It makes your blood, like that, like watery texture, I guess. And it delivers the blood plasma to the tissues in your body. And when plasma leaks out of capillaries, it becomes interstitial fluid. Interstitial fluid is basically the fluid surrounding the cells and tissues. So, what happens? So, the fluid leaks out of the capillaries, right? And so, we have about 24 liters a day of blood plasma, which is interstitial fluid. And 20.4 liters, not 100%, you see, becomes from interstitial fluid to blood plasma. The remaining becomes lymph. So some fluid can't return back to the capillaries and become lymph. And lymphatic capillaries are tightly related to the blood capillaries. And they have one-way flaps that ensures that they cannot go backwards. And it can only travel in one direction. And they are capable of regenerating themselves. So if you do damage one, your body can repair them and replace them in tissues, and it's easier to repair than blood vessels. So lymphatic vessels, so the lymph enters the lymphatic capillaries and they merge into lymphatic vessels, and then lymphatic trunks, and then lymphatic ducts. So the process is capillaries, vessels, trunks, and ducts. CVTD. Okay? And so what happens is the lymph enters the lymphatic capillaries merge together to make the lymphatic vessels. Lymphatic vessels, they only have one-way valves to them. So I'm gonna go through this with you guys. So lymphatic capillaries go to lymphatic vessels, and then afterwards it will merge even bigger lymph nodes. Okay. No, not merge into lymph nodes, they pass through lymph nodes. So it's not a merge here, it's just passing by. It's like saying, hi, I'm gonna go through. You have lymph nodes all over your body, they're scattered all over. So lymphatic capillaries go to lymphatic vessels, and it goes, and each one of these goes through lymph nodes to go through the next step. And what happens is after the lymphatic vessels it pass through the lymph nodes, it will continue until they merge into larger lymphatic trunks. And there are about 9 lymphatic trunks, and they merge into the final two large lymphatic ducts. And these empty into the cardiovascular system. So then eventually it goes lymphatic capillaries, lymphatic vessels, and from there it's supposed to be go lymphatic trunks and then lymphatic ducts. And lymphatic capillaries, they merge to create lymphatic vessels, merge into lymphatic trunks, and then merge into lymphatic ducts, which are the last vessels that would dump the lymphatic fluid back into the cardiovascular system. And there are 5 sets, but 9 in total, so there are 4 that are a pair and 1 without a partner. As you can see here, you see they have left, right, left, right, left, right, left, right, left. The interstitial trunk is the loner. Okay, and let me explain where all of these are. Okay, right bronchomediastinal trunk and left bronchostenial trunk. These two drain the thoracic wall, lungs, and heart. You see where it's located? Thoracic ducts are right here, right? So it drains, let me see. So right here, the heart, the lungs, and the thoracic. Subclavian trunk, right and left. This one drains the lymph out of the upper arm. Upper arm, look here. Jugular trunk drains from, it's even higher, so it's head and neck. I hope that makes sense, guys. Okay, but the loner right here, this loner right here, he's a little different. He's a little special. He drains from the stomach, intestines, pancreas, spleen, and part of the liver. And this is very important because it makes sure the extracellular fluid drain out of your lower parts of your abdomen. So this guy, even though he's a loner, he's doing a lot of work. So it was the stomach, so low stomach right here. Your lower intestines right here. And then pancreas, your spleen. Okay, brief overview. Right jugular trunk, head and neck, subclavian, upper arm, bronchomediastinal, thoracic walls, lungs, heart, and the lower intestinal trunk, stomach, intestines, pancreas, spleen, and part of the liver. Lymphatic ducts. Lymphatic ducts will drain fluid from the lymphatic system back into the cardiovascular system. So as you can see here, the thoracic duct is 75% of it. So it does most of the work. And the other one is the right inguinal, um, the right lymphatic duct. The right lymphatic duct is about only like 25% of it. And as you can see here, they have a cisterna chili. The cisterna chili is basically just a large portion of it. So yeah, it's like It's located in the abdominal pelvic cavity, and it's just like this little big little bulb right here. So, and then as you can see, this 25% is the right lymphatic duct, while this whole entire rest of the area is the thoracic duct. So 75, write it. Oop, that is very ugly. And 25, right there. And basically, yeah, they're just draining fluid to the cardiovascular. Lymphadenitis. Oh yeah, and I wanted to add a little bit more. So the thoracic duct continues from the top to the bottom and dumps all the lymphatic fluid back into the cardiovascular system, where the left internal jugular and the subclavian veins meet. And as you move up, in addition to the lumbar and additional trunks, joining the left jugular trunk and left subclavian trunk and left bronchus mediana, they're all joined and dump lymph into thoracic duct. So all this entire area, they're like ganging up. They're like, okay, hey, like let's go dump into thoracic. So all those parts all dump to thoracic. So the right lymphatic duct is shorter and is not as long, and it drains the right jugular, right subclavian, and right bronchial mediastinum. All the lymph gets dumped into the right lymphatic duct and the right subclavian vein, and before it meets into the superior vena cava. So yeah. There's three trunks dumping into them. The left side and the right side, but this side is shorter. It has to go to superior vena cava at the end. Endophotonisis. So this is the blockage of the lymphatic vessel. And you can see how the arms, this is because there is excess fluid that is not being drained. And it can really affect the quality of life. So, even if you drain the fluid from these people, there will still be a lot of tissue damage left because when you enlarge an area like this, it is very hard. Like, let's say you have fluid coming out, right? It's very hard for it to go back like this again because you see this area, your skin is all stretched out. It's all enlarged and puffed up, and it's hard for it to go back to this now. It's really hard, even if you drain the fluid. And it's basically when lymph is built up and the blockage can trigger edema. And edema is a swelling of caused by excess fluid in the tissue. And the causes are parasitic worms, chlamydia, autoimmune diseases where your own body attacks. Okay, so you're right here, own body attacks its lymph systems. Okay, and also chronic exposure to dust, the irritating particles. This one can and the treatment, like if you have chlamydia, sometimes they do give you antibiotics and this can help cure it. So it's better to have preventative checkups and to get tested. So lymphatic organs have an exterior capsule of connective tissues. They have the thymus, the spleen, the lymph nodes, and lymphatic tissues have no capsules. Like tonsils, they are not true organs because they don't have a connective tissue separating them from the rest of the tissues around them. Primary lymphatic organs have stem cells that create immune cells, like the bone marrow, the thymus gland. Secondary lymphatic organs and tissues, they don't create new cells. They attack pathogens and lymph nodes, and they have lymph nodes, spleen, lymphatic nodules, and tonsils. Okay, so the primary lymphatic organs, this guy right here, this guy is the one that has, the white blood cells. Well, this guy is the one where immune responses occur. Like lymph nodes, spleen, lymphatic nodules, that's where they occur. Okay, so I would go into more of like true organs and stuff like that. So, but I'm gonna go through the thymus really quick. So this is located in the medullum sternum, and it's between the sternum and the aorta. And people say it's kind of like the heart shield. See your heart's right here? And your thymus is just like a little covering. It's like, hey, like I'm gonna protect you. I'm your warrior, your guard, I don't know, security. And it's larger in children because as we age into adults, it atrophies because the reason why is the granular tissue gets replaced by adipose tissue. So in children, it looks a little bit more red because there's more blood vessels. But when you become an adult, it gets more yellow because it's being replaced by adipose. So it has true capsule because it's surrounded by connective tissue, and the connective tissue capsule extends inwards into structures called trabeculæ that divide into lymphatic tissue or thymus into individual little nodes. So thymus is where T cells come to mature. So T lymphocytes move over to the thymus to mature into mature lymphocytes. T cells are part of your immune system. Their job is to attack any pathogens that come into your blood by circulating chemicals on them within your thymus, in addition to T lymphocytes. They have other immune cells like macrophages, dendrite, and dendrites are part of your immune system too. They're found in the skin, and they are and thymus gland, they look like trees. Okay. So basically, let me explain the T lymphocyte system. Okay, let me erase this real quick. So the T lymphocytes, if they fail any test, so okay, I'm gonna break it down. I'm gonna break it down. Okay, so dendrites, right? They are the teachers. T lymphocytes are like little guys. They're like, okay, they're like little students. Oops. How much? Oops. Okay, I'm gonna write this. And then they have these T lymphocytes. And if they fail any tests by the dendrit, okay. So the dendrites are part of your immune system, and they are given tests. So these guys are the teachers. They're I call them the little teachers. I call these the students. And basically, what happens is the if the lymphocytes fail any test by the dendritic cells, the macrophages will eat them up. Okay, so it's like, oh, like Android's like, hey, here's some lessons, and the T lymphocytes fails. Boom, eliminated. Okay, that's macrophages. They're like these little red guys with the red guys. They're like, ump, ump, ump. So T lymphocytes, goodbye. You're not coming back. And it is important because if you had bad T lymphocytes that escape out into your immune system, you might end up with an autoimmune disease where your immune system attacks your own body. And your thymus gland is involved in making sure that your T lymphocytes are prepared to fight the pathogens. And yeah, so this is actually a good thing. You want to make sure that the T lymphocytes are passing lessons by the dendrites because you don't want an autoimmune system that attacks your own body. Like yeah. And then for the spleen, what does the spleen do? Spleen is a 5 inches long, and its main job is to monitor for blood, for pathogens, and it watches everything that goes by blood and attacks and gets rid of it. And it's a site of red blood cell phagocytosis. So when red blood cells get end of life cycle and they get flexible, the macrophages that hang around the spleen break down those red blood cells. It also does iron recycling, so it makes sure that they recycle the hemoglobin, not red blood cells, or you become anemic. It also aids in immune responses and monitors blood for pathogens. It stores red blood cells and platelets. Yeah. It has really thick capsules made out of dense connective tissue. It has lots of blood into it, and the huge artery that feeds blood into the spleen is called a splenic artery. One spleen gets into blood gets into the spleen, it separates from the capillaries. A spleen will monitor the blood and returns the blood through the splenic vein. So, mm, I should make this different colors. Okay, so this is the splenic artery, and then this is the splenic vein coming out. Blood goes in here, being monitored. Blood comes out through the splenic vein. Lymph nodes. So there's bean-shaped organs. You see this little green right here? Bean-shaped. They're very small. They're like kind of cute. Like, like you see, those are the little lymph nodes around your body. And the variation, like, is varies from person to person. They recognize and destroy pathogens that are in the lymph. So lymphatic vessels are bringing lymph over to it, and there's no blood vessels that bring blood to the lymph nodes. So the lymph node is still organ and needs blood supply. So lymph node tissue can also have oxygen. So in addition of lymphatic vessels, it will also have blood vessels to bring blood. So basically, these guys are like, hey, like we're making sure there's no pathogens. We're gonna fight off the pathogens. They have immune cells in it, and yeah. And lymph nodes. They are bringing lymph over to it. There's blood vessels that bring blood to the lymph nodes. And there is, let me show you. So the area of indentation in the side of the lymph node is called the hilum. Hilum is where the artery and vein coming into the lymph nodes. And they have the exterior capsule, and outside the lobule is considered the cortex. So outside here is the cortex. This is the medulla, trabeculae is this middle, German center is the middle of these little cells. Germinal center is where the B cells hang out and are producing antibodies. And they are also true organs. So they have afferent lymphatic vessels. They bring lymph into, let me draw it in. So they're bringing lymph in here, and they'll bring and then they swirl around all the white blood cells like macrophages, B cells, and you remove any pathogens. And it's only in one direction, while the efferent take lymph away. Let me find it. They're taking the lymph away, right? E for exit, A for arrive. The clean lymph is going to exit the lymph node through the efferent lymphatic vessel and go back up towards the heart. Lymphatic nodules do not have an outer capsule. They are not true organs, and they are egg-shaped mass of lymphatic tissue. They're seen in the GI tract, the urinary tract, reproductive tract, and they may be single or in groups. So they are the sites of cell proliferation. Here, so let me explain it. So cells reproduce themselves to create a large immune system. So you've been sick a lot. Sometimes your doctor checks in your look like he touches your neck to see if your lymph nodes are enlarged and swollen. The lymph nodes they grow in size. So when you have an infection of the white blood cell, the lymph nodes will be bigger, it'll grow bigger, and it'll defeat the pathogens in your body. They're basically protecting. But there's a hair trigger in dividing itself, so it's susceptible for developing cancers. And the cancer of lymph nodes is the Hodgkin's disease, which is one or more lymph nodes that are enlarged. And they are attacking the lymph nodes in the cervical area, which is the head area, or in the axilla, and it's common in males. The non-Hodgkin's lymphoma disease, it tests DNA and tumor, and it's common in older patients where they have enlarged spleen, where they have non-Hodgkin lymphomas, and it's enlarged in the neck. And that is all for lymphatic system.